Congratulations, you got to the end. This is the last video. Well done. Okay, I hope it won't be too long. I'm just going to do another live Excel thing. I finished with the historical var. Hang on, I don't think I'm sharing my screen. So let's, hang on, share screen. Here we are. Okay. Right, so what am I going to do? I'm going to look at these returns, and I'm not going to do value at risk. I'm going to look at optimizing portfolios. So again, I just copy this sheet. It's easiest that way. Move to the end, create a copy, rename the sheet, and I'm going to call the sheet optimal portfolios. Right, so I'll get rid of all that. Don't want that. Delete, delete. There's lots of different ways one can do this, but the first thing I want to do is to show you that how to do that variance of the portfolio W prime VW. So I'm going to take all the data again, and I'm just going to put up a vector for W, which could be anything, and I'm going to little w, there we are, and I'm going to have a matrix V. So that's my W, and then I'm going to have a matrix V. So the W is going to go there. Let's make that pink, and the V will go here because it's a 2 by 2. There's only 2 assets here. Obviously, if you had 3 assets, it would be 3 by 3. And then we need to have our W prime, W transpose, which is going to be there and there. Actually, why don't I do W transpose here? That's the order it was in. So that would be there and there. There and there. Da-dum, da-dum. Okay, get rid of that. And then the W will be there, and that will be like that. So, for example, say the weights are 0.4 and 0.6. I'll make it red because I want to change those weights to optimize my portfolio. I won't necessarily get a minimum variance portfolio if I have weights of 0.4 and 0.6. So this has got to be equal to that, and this one has got to be equal to that. That's the transpose. And this one is going to be equal to the variance of my portfolio returns, so of the Bitcoin returns, B and B. And, oh, doesn't like variance. What is it called then? Variance. Oh, variance.p. Is it the covariance is okay? Is it var? Just VAR? I suppose it is, even though, yeah. So var p, so P and S depends whether you divide by n minus 1 or not. Okay, so let me call it var p. I don't want to divide by n minus 1. And this is the variance of C. And this one is the covariance of the two. Covariance P of B and C. Yeah. And this number is equal to that. All right. So now I can do my portfolio variance, which is, I have to multiply M mult. So it's multiply W transpose, this, multiply that, times the matrix, so that's M mult, this matrix. Okay, but I also want to multiply the result by the W. So I'll have to M mult the whole result times the W, which is, oh, I can't see it. So it's F4 and F5. There we are. And now if I do Control or Command, depending on whether you're PC or Mac, Command for Mac or Control for PC, hold that down, hold the Shift key and press Enter. Oh, doesn't do anything. mmult, that. No, it is Control, sorry, not Command, it is Control for Mac as well. That's the variance, and then the portfolio volatility is going to be, now, all right, the variance is a daily thing, isn't it? So the volatility has got to be square rooted times 365. So I've got a portfolio volatility here of 90%. All right, 91%. So that's pretty high, isn't it? But it could be that I might be able to minimize that volatility, get a minimum variance portfolio. But I'm a bit worried about that because it might want me to go short and then things could get very short and very long. But let's see what happens. So I want to minimize the portfolio variance or volatility, it doesn't matter, either of those. And I want to do that by changing the weights. So hang on, I want the weights to add up to 1. So I've got to make this 1 minus that, yeah? So it's only the weight on one of them. If there were 3 assets, I could change 2 of them, but not the third, because they've got to add up to 1. All right, well, shall we see what I can do using something called the Excel solver. So that's in tools, isn't it? Excel tools. I thought I was trying to find it in add-ins before, but actually it's in tools. Oh, there we are, solver. So this is an optimizer, okay. Set objective, actually I want it to be F4. F4, that's that one there. Okay, so if I click on it, it just gives me the name of the spreadsheet. To the minimum by changing which cell, oh no, I wanted my objective to be the variance, the optimal portfolios. So this one, that's F6. Is that F6? Yes. By changing the weight, right? And there's lots of different optimizing methods, simplex, evolutionary, GRG. But let me see what happens. It's probably going to go completely bonkers. It's just disappeared entirely. Oh, there we are. Okay. So I managed actually to keep them positive, probably because they're so, there are times when they're not particularly highly correlated. And the portfolio volatility, smallest I can get is 82%. So that's how to use the solver to minimize. Or I could do something like, I could keep an equally weighted portfolio. It doesn't have to be the minimum variance portfolio. I could also look at the mean returns and set some target mean return, but that's a bit more complex and I'm not going to do that. That's all about efficient frontiers and so forth, not in this module. Just a minimum variance is fine. And now we can find, for example, the Sharpe ratio with the resulting portfolio. So let me look at the portfolio return. I need to get a time series for this in order to get the Sharpe ratio. So that's it's going to be 88% always, so I've got to fix that, times this return, plus 1 minus that, which is this, and fix that too, times this return, and that's my portfolio return, the weighted sum of the asset returns. That was the very first formula we saw. Put them in percent. And so now I can calculate, let's put a bit of space here. I can calculate the Sharpe ratio. Okay. Just save this, by the way. Be careful to make sure that, I'll just save it for now. It's an old version of Excel. I'm just going to save it again though, hang on. I'll do that later. Just wanted to save it before I did too much, as I thought, oh, I've done all this, and if I lose it, then I've got to make all the videos again, which, having got to the last one, I don't really want to. Sharpe ratio. Okay, so that's, first of all, I need to find the, I've got the portfolio volatility there, that's fine. So it's like the annual standard deviation, there's no problem. But I do need to find the mean return in annualized form. So that's going to be the average of D. In annualized form, it's times 365. We don't use a square root for the mean. So that's the average return. Annualized is 117%. It's not surprising over those years, more or less what people have been earning. And so the Sharpe ratio, and let's forget the risk-free rate, it's like 1%. It's not going to make much difference to that mean, is it? Just divide the two. Actually, this formally is called the information ratio, yet another risk-adjusted performance metric. I don't want that to be in percent. So a Sharpe ratio of 1.42. Any Sharpe ratio above 1 is really, really good. But it's, yeah, Sharpe ratio above 1, jolly good. If I were to put this back to 0.5, for example, an equally weighted portfolio before optimization, then the Sharpe ratio would be 1.57. So, you know, just because you get a minimum variance doesn't mean to say you maximize the Sharpe ratio. Equally weighted portfolios are very difficult to beat very often. But of course, to keep that, I mean, we've assumed that the weights are constant, and to keep them constant requires rebalancing quite a lot. And then you've got the transaction costs, which we haven't looked at. So whenever you try and keep weights constant rather than holdings constant, like 10 Bitcoin and 4 Ether, and let the weights change because of that, it's a much easier way to measure things. But that's, again, going beyond the scope of this module. I think I'll sign off for now and say bye-bye.